Dear students, this is our 40th lecture on named reactions, and in this lecture we will discuss about the details of stop condensation. Stop condensation basically is the synthesis of alkylidene succinic acid or its derivatives, and these types of unsaturated alkylidene succinic acid derivatives, they are synthesized when we react esters of succinic acid with any aldehydes or ketones, and the product of this condensation between these two reactants is known as Stobb's condensation. The reaction take place mostly in metal alkoxides or the strong bases like potassium tertiary butoxide or sodium methoxide, and one equivalent of this strong base is used up. Basically what happens is in the presence of this strong base, this carbon or this carbon, these are the equivalent carbon, because of the presence of these ester groups which are electron withdrawing in nature, a carbanion will be generated, and that carbanion will attack the carbon oxygen bond to give us these types of unsaturated half ester salts which are formed. And these half ester salts on hydrolysis in presence of any protonic acid like HCl, they are converted into alkylidene succinic acid derivatives as the product. The first reaction which was reported by Hans Staub on the name of the scientist, this Staub condensation is known as. The first reaction was between acetone and diethyl butanoate. So when diethyl butane dioate was reacted in the presence of sodium methoxide as a strong base, followed by hydrolysis with HCl, then the corresponding alkylidene succinic acid ester was formed as the product, and this was called as the Staub's product or Staub condensation product. Similarly, another example is this ketone benzophenone when reacted with diethyl butane dioate. Again, when reacted with the strong base, will give us the alkylidene succinic acid ester, which will be hydrolyzed to the corresponding acid esters as the product. Now, as far as mechanism is of this reaction is concerned, in the first step, the strong base will generate the carbanion on the diethyl butane dioate, and this carbanion will attack the electrophilic carbon of the carbonyl compound, that is aldehyde or ketone, and this oxygen now will acquire the negative charge. Then this negatively charged oxygen will attack the other electrophilic carbon of the ester with the ultimate elimination of ethoxide ion, and this 5-membered intermediate will be formed. Now this proton is again an anesthetic proton, and under alkaline conditions or basic conditions, this will be abstracted with the opening of this 5-membered ring, and we will get the half esters as the product. So this is how the condensation of succinic acid diesters with aldehydes or ketone will lead to the formation of half esters of succinic acids as the products. Then as far as applications of Stobb's condensation is concerned, Many types of organic compounds they can be synthesized through stop condensation, and one such synthesis is synthesis of benzofurane derivatives. Benzofurane derivatives they can be synthesized from substituted furanes through cyclization and then generation of the benzene ring through stop condensation. For example, if we are having these types of 2-acyl furanes, when these are condensed with succinic esters, then in the presence of strong base and then hydrolyzed by HCl and water, as we have seen previously, these diesters they will react with this carbon oxygen double bond and the half esters of the corresponding carbonyl compound they will be formed. So these types of carboxylic acid derivatives they are formed, and when these carboxylic acid derivatives they are reacted with acetic anhydride in presence of strong base, then a positively charged electrophile will be generated, which will undergo electrophilic aromatic cyclization, and we will get these types of benzene ring formation to give us benzofurane derivatives through stops condensation. Similarly, we can use furane aldehydes also, and furanaldehyde, that is furan 2 carbaldehyde, when reacted with gamma keto acids in presence of acetic anhydride, again they will undergo the same type of reaction, Stokes condensation, to give us these types of alkylidene furanone derivatives. And then these alkylidene furanone derivatives they will undergo Friedel-Crafts reaction to give us 4-aryl benzene furane 6 carboxylic acids as the product. So we can synthesize benzofurane derivatives through stop condensation of acyl furanes or furanaldehydes as the starting materials. Similarly, we can synthesize beta UD small as the product. This is a biologically active alcohol. This can be synthesized from these types of keto esters. This is again gamma keto esters. This is alpha carbon, beta carbon, and gamma carbon. So when gamma keto ester of this type, methyl 4-oxocyclohexane 1 carboxylate, is reacted with tertiary-butyl glutarate in presence of lithium and liquid ammonia, the addition of the carbanion will take place across this carbon, and this oxygen will acquire negative charge, and this will become OH. So basically addition of the carbanion at this carbon will lead to the formation of this type of triester, and then this triester will undergo dehydration over here, H from here, OH from here, this carbon-carbon double bond will be formed, and then these groups they will get hydrolyzed to these types of carboxylic acids they will be formed, and this carboxylic acid formed then will undergo cyclization in the presence of polyphosphoric acid to give us these types of unsaturated keto acids. So alpha beta unsaturated keto acids they are formed, and these alpha beta unsaturated keto acids then they can be converted into beta UD small as the product through different types of reactions. First reaction is the conversion of this keto group into this methylene group, and then reduction of this carboxylic acid derivative to this type of tertiary alcohol. This can be achieved through Grignard reaction. Then another type of application of Stokes condensation is which is very commonly used is synthesis of tetralone derivatives. Tetralone derivatives, they are very biologically active compounds. So different types of tetralone derivatives, they have been synthesized through Stokes condensation. For example, this tetralone derivative, that is 8-methoxy 1-tetralone, has been synthesized through Stokes condensation. This 8-methoxy 1-tetralone is useful in synthesis of AARQ 501, which is a metabolite of human blood, and this compound is also useful for the study of dopamine and serotonin receptors. So this 1-tetralone derivative is synthesized when we condensed metamethoxybenzaldehyde with diethyl butane dioate under the presence of alkaline conditions, sodium methoxide, methanol, and 5 molar sodium hydroxide. Again, same thing, condensation of this carbon-oxygen double bond with one of the methylene group will take place, and we will get this type of unsaturated ester. Then this unsaturated ester will be converted into on hydrolysis will give us unsaturated acid, and this unsaturation will then be then this will undergo catalytic hydrogenation to give us these types of saturated diacids, dicarboxylic acid. These dicarboxylic acids, when reacted with bromine in acetic acid, they will undergo Friedel-Crafts bromination at this carbon, and we will get the corresponding bromo derivative of these saturated acids. Then these bromo saturated diacids, in presence of concentrated sulfuric acid, they will undergo cyclization at this carbon to give us these types of 1-tetralone derivatives. So this bromotetralone is formed as the product. Then this bromotetralone will undergo decarboxylation in presence of sodium sulfide, silver nitrate, and methanol in 77% yield. Then this 1-bromotetralone will undergo debromination in presence of palladium charcoal hydrogenation to give us 8-methoxy tetralone derivative. So basically metamethoxybenzaldehyde and diethyl butane dioate will be converted into these types of tetralone derivative, which are biologically active compounds. Then next application is again the synthesis of tetralone derivative. Now these are 2 tetralone derivatives instead of 1 tetralone. So basically these types of compounds, 2-acetyl 7-8 dimethoxy 1,2,3,4 tetrahydronaphthalines, they are converted into tetralone derivative, and these derivatives, they can be synthesized through Stokes condensation. So only difference from the previous example is, in the previous example we have used metamethoxy benzaldehyde, whereas if we start with 2,3 dimethoxybenzaldehyde, with the same type of succinic ester. Under same conditions, we will get the saturated diacid, and this diacid again under similar conditions will be converted into these types of tetralone derivatives. And these tetralone derivatives, they will be converted into the corresponding aldehyde. This carboxylic acid group will be converted into an aldehydic group through three reactions. First is in presence of zinc amalgam HCl. You know, this is called as Clemenson's reduction. Then followed by lithium aluminum hydride reduction, means metal hydride reduction, followed by chromic oxide pyridine oxidation. These three steps, they will convert this carboxylic acid into the aldehydic group. Then this aldehydic group, when undergoes Grignard reaction followed by chromic anhydride pyridine oxidation, this aldehyde will be converted into this type of ketone. And this ketone, which I have told you, is 2-acetyl 7,8-dimethoxy 1,2,3,4 tetrahydro naphthalene derivative. Then through different reactions, basically three more reactions take place to convert this compound into 2-tetralone derivative. And in these three reactions, what will happen? First, this compound will undergo Baeyer-Villiger oxidation, and the product of Baeyer-Villiger oxidation will then undergo alkaline hydrolysis followed by chromic acid oxidation to give us these types of 7,8-dimethoxy 2-tetralone derivatives. And again, these tetralone derivatives, they are also biologically active compounds. Then another biologically active compound is rishitinol. This is phytolexin susciterpene, which is produced in stressed white potato, that is Solanum tuberosum, as a response to the infection by some fungus, which is Phytophthora infestans. This the synthesis of this compound can also be achieved by Stobbe's condensation. So if we start with these types of aldehyde, 2,5-dimethyl-benzaldehyde, and react with again succinic acid esters, that is dimethyl butane dioate, in presence of sodium hydride and 5% HCl, followed by catalytic hydrogenation in presence of palladium and charcoal. This will be converted into this type of saturated diacid. You know, with these conditions, first unsaturated diester will be formed, then that will undergo hydrolysis in presence of HCl to get converted into diacid. Then unsaturated diacid will become saturated due to catalytic hydrogenation in presence of palladium and charcoal. Then these types of diacids on cyclization with sulfuric acid will lead to the formation of these types of tetralone derivatives, as we have seen in the previous examples. And then these tetralone derivatives, they undergo a esterification reaction in presence of HCl and ethanol. The corresponding ethyl ester of this carboxylic acid will be formed, and this ester derivative through different reactions then will be converted into this type of rishitinol, which is as I told you, is a phytolexin susciterpene. Now this ester first reacts with Grignard reagent. This will be converted into these types of derivative, and then this methylene group will be oxidized to alcohol, and then reduction of this will also take place. So through different steps of reaction, these types of tetralone esters, they will be converted into rishitinols, which are very biologically active compounds. So you can contact me through telephone or email, or you can visit our website. Thank you very much.